So, good morning, everyone.
Can you? I'll leave.
Hello, everyone. Welcome to the very first technical session of on robotic operating system, wherein the session will be taken by our two members from e-Yantra family, which is Jason Jose and Archit. So, uh, Jason, over to you.
Yeah, so I guess it's all audible and clear. We'll start
Yeah.
with the screen share. Okay, so I hope my screen is visible.
Yeah, we can see.
Yeah, okay. So when robot operating system comes to mind, uh, what is the first thing which comes to your mind? Like when we say ROS and all, like, you can enter in the chat box. So the term robot operating system. Any ideas? Okay, so actually, when we say this robot operating system, we quickly think of a robot and it's functioning with different system sensors and all, and we use the software to like make a foolproof system to communicate the data, to transfer the data and all. So what happens is when we have this so many sensors in this robot. In fact, when you see this picture also, that is this robot, we see there is a camera as well as there would be speakers, microphones, and then there would be actuators, right? So when we are moving, when the bot is moving around, it need a system that can take control of all these things, of transferring this topic and all that thing. So this is where ROS comes into picture. That is, there there has been developed a middleware, that is robot operating system, and it helps you in making this part of transferring of our communication very easy. Like it would be literally like you have subscribed to an YouTube channel and you are getting a video on day-to-day basis. So it's as simple as that. You will just create a particular address and particular name of data packet, and in the other side you will request the same data and you will get it. You need not to configure all of those protocols and everything. You just use this framework. So also there is this quick question. You also know, like many of you know, that robot operating system is not an operating system like Linux and Windows and so on. So what are your guesses? Like, why is it called robot operating system if it's not an operating system? That's a question which you need to ponder on. You can give a quick reply on the chat. Maybe we'll take some valuable answers or doubts also. Yeah. So middleware, yeah, it's a middleware. So actually, what happens is in operating system there are these features of uh, what is called as scheduling, task scheduling, management of task, and then transfer of data and all, right? So since this framework satisfies all these conditions, that is the reason it is called as operating system, where in fact it is not the same way when we say this robot operating system. So that is one thing which you can remember when moving forward, that it is not actually an operating system, which in fact is like the Windows and all, or the Mac OS and all. But in fact, it is like a framework which you can even install in the microcontroller, microprocessors, and on any laptops, and use this framework to communicate between the sensors and actuators of a robot. So there is this brief introduction video will like to present. So yeah. So this is what about ROS.
Building robots is
Maybe the
difficult.
audio.
Motors, sensors, software, and
Okay,
batteries
so since
all work together seamlessly to perform a task. But there's a way to simplify the process. The Robot Operating System, or ROS, is free and open source software that defines the components, interfaces, and tools for building advanced robots. Most robots are made up of actuators, things that move, sensors, things that read the world, and control systems, or the robot's brain. ROS helps developers quickly build these components and then easily connect them using ROS tools called topics and messages. These messages can be recorded using ROS bag files or logs for easy testing, training, and quality assurance. Messages can be easily sent to a variety of visualization and teleoperation tools. With ROS, you can work with a simulated robot instead of the real thing, which some call a digital twin. This also makes testing and training easier and more effective. ROS supports hardware interfaces for many common robot components like cameras, LiDAR, and motor controllers. ROS's modular architecture allows developers to build robots free from vendor lock-in or licensing fees. ROS can also work with just about any component. Anything that has a software interface is fair game. ROS 2 supports micro-ROS, a variant of ROS that runs natively on embedded microcontrollers running real-time operating systems. ROS's framework of common tools for robot development allows you to focus on addressing your problem, not on reinventing the wheel. This is why hundreds of companies, from small startups to Fortune 500 organizations, academic research labs, and government agencies, choose ROS as their robot development platform, and have downloaded over 500 million ROS packages in 2020 alone. However, ROS is more than just software. ROS is also a community of highly trained and pragmatic roboticists applying advanced robotics to every conceivable application, sharing their solutions with each other. When you choose ROS, you're tapping into a worldwide talent pool, community resources, and an ever-growing ensemble of services built on top of ROS. These services include logging and diagnostics, fleet management, deep learning data collection, testing, and quality assurance, and a whole lot more. The ROS community is now tackling every robotics market, including agriculture, factory logistics, autonomous vehicles, service robotics, food preparation, heavy industry, drones, planetary exploration, and so much more. This community is supported by the ROS Technical Steering Committee. These organizations use ROS to build better code faster, hire talented developers, and accelerate their time to market. To learn more about ROS and how it can be used to develop your robot, visit ros.org.
What name? Answer is 26. 20. Oh, Z. Z.
Okay, so why ROS? That's the first question. And in fact, in the video also, you might have
Hello.
heard that there is this reinventing the wheel phrase being used. So we need not to reinvent the wheel. When let's say there is this package already developed, or let's say there is this module already developed for a camera to detect a person or detect an object and to move accordingly. So when you are making your own robot, you need not to do it again from scratch. You can just use that particular thing and just change some parameters here and there, telling this is where my camera is, and that's how the magic works. So it's literally you can just directly port that particular package and use it. So it will be very easy if you are using ROS, because the framework is same, the packages are same, the dependencies are also listed, so it will be very easy and modular. As well as there is this communication part. So you might have seen that there are many companies which are using this. So within a network, to have this standard protocol of particular data to be communicated, all those things are easily available in ROS. Also, in this framework, they give this part called the simulation support as well as the hardware support. So in fact, when we are dealing with robot, the main problem or main constraint many of the companies as well as the amateurs face is that we don't have access to that big robots or the expensive ones which are very accurate or which are very precise in their sensor readings and all. So what we do first is we test our algorithms in the simulations. So there are different kinds of simulation tools which ROS do support, and at the same time the packages which can be used in hardware can be used at the same time in the simulation to mimic. Although there would be some differences, but yeah. So it in fact helps us to test our algorithm in without directly going to the hardware. So it's not like what you think, that simulation happens something else in hardware, but it would be almost similar. While it comes to hardware, there would be some fine tuning left. So simulation helps a lot. And then there is this global community and an open source market. So does anyone know about open source? What is open source? You can enter in the chat. Okay, we post a question. What is open source? Okay, so in the global community, what happens? Multiple, since it is an open source, multiple people all around the globe will contribute into this. So let's say if you are making a particular sensory for a sensor, you particular make a package. So package is like in fact you are making a particular dependencies, and these are the actions which to be done for a particular sensor when you are interfacing. So once you make it and export it somewhere on GitHub or some on apt or something, that happens, another person around the world can also get help from that. He will directly take your code, directly take your package, keep it use in his laptop for same sensory installment. So many people from all around the globe are similarly contributing to this freely, because they are getting this from the community freely. So in order to get advantage, we are also giving to the community. So this is how it works. We help each other all around. And yeah, the more important thing is it's a multi-robot communication. So if have you heard of swarm robotics? So you can give an example of swarm robotics if you have heard in the chat. So where have you heard swarm robot, or have you heard it in drones only, or where else have you heard the term swarm robotics? So in swarm robotics, there is this multi-robot. Will be multiple robots moving around, and they need to communicate with each other. What are the obstacles coming, and which path is not to be taken, or what are the information on this particular road and all. So for that also, ROS is very beneficial. You need not to write the very tedious programming into each of that, and manage all of it. Instead, you can just directly use this framework and communicate between the robots. So it's very easy in terms of multi-robot communication. Next is the abstraction and programming language feasibility, which I guess all of you might know. It supports Python, C++, and when it comes to ROS 2, that is the new version which we'll be looking on today, as well as in the themes which are in robotics competition, is that, and perhaps that is the one which all the companies have shifted to. So ROS 2 has this flexibility with all the programming languages like Java. You name the programming language, it supports, because that's how it's written. It has this base layer, and then it has the wrapper layer of all the other languages. So it's easy to interface with any to write program in any language. Yeah. and it's a multi-platform, so it's even available in Windows and all that. So since that multi-platform it is supporting, so in Windows and all, it's easy. So since also the developers in Windows who are for this ROS are less, that's why uh, most of the things most of the things might be less available in Windows and Mac OS, but yeah, mostly will be available in Linux. But yeah, since it supports multi-platform, you are always free to explore it. So this is our last year's theme, which involved ROS, specifically one. So you can see that it's traveling around the arena, detecting the fruits. So first in simulation and then in hardware. So there is no much difference between the simulation and hardware. Only there would be some fine tunings and here and there changes. So this is the hardware where it scans for the fruits, does manipulation of the arm, navigation and all around. And yeah, so this was done all with connected people from all over India. So students from different part of India come together. This is another thing. So yeah, so basically it detects the Aruko marker, and you have to navigate around, taking the tracing the figure whatever is given as input. So this is where, if you have seen in the previous video also, it's easy to control multiple things using ROS. You just have to create package and publish on a topic, and then it's easy. So it's not as difficult as when you are creating everything from scratch. So if you're creating navigation from scratch, you have to write everything, and for a new robot you have to write again everything. So maybe so what ROS helps is, if a person has done already this, he can take it from the internet and easily install in his laptop and do it all the packages and with some little modifications. So this was one of the theme again, where you have to draw the figure which was given. Yeah, so this is another interesting theme, that is Sentinel drone, which also use ROS. So since in drone there will be multiple things, like you the perception, as well as you have this to roam around, and then you have the things to be controlled while in a flight or in when you are moving around. So all these things will be handled by drone. So in this theme also you can see the drone is flying around and detecting that yellow box as an obstacle. So not an obstacle, but as some kind of unidentified object, and then locating it on the map. So the drone is stabilized using PID control, and this yellow box or whatever the unidentified object is, it needs to be reported onto the map using GIS. So that is called as georeferencing. Okay, so next question is like, why learn ROS 2? So from the before shown videos, do you have any doubts? You can clear it up quickly. So in the drones and all, we see that uh, there are different control system going on. There is perception going on, and in the Krishibot theme, which you saw in the first, is where you see there are different things like similarly, which will be in cosmologistic, that perception, manipulation, and all that things are going on. So yeah, why learn ROS 2? So in ROS 2, since it's the second version of ROS, what happens is in ROS 1, which was the first version of ROS, had these problems called as masters. So you need a master to be present all the time in order to communicate with the nodes all around. So a master used to be there, and then uh, there was this problem called if the master disconnects everything, all the system stops all of a sudden. So in order to avoid this, ROS had this new version called ROS 2. So where there is no master, we will look onto it more about how it works and all. So next is this, yeah. So this is an industry standard version. So since most of the industries have this robot swarm robots going all around in their in their factories and in their warehouses and all, so they require this no master network or master free network. So that's why they also prefer ROS 2. Next is that there is this career opportunities, of course. You are directly getting chance to do with the industry standard things. And finally, research and innovation. So as you have seen in the earlier slides, the main functionality is that you don't need to reinvent the wheel again and again. So once you are doing a research with a robot, you need not to build everything from a scratch for a robot, like navigation and everything to move around, to just do a research for a perception thing. If you want to do a research for perception or for an image processing thing, you can directly take the ROS framework and its program for all the navigation purpose. Just put it in the bot, make it work after some fine tuning, and then focus more into your research of your main domain, that is image processing or manipulation or navigation. So that's how it helps a lot in research as well as in innovation. Or also, if you want to prototype something fast, very fast for a startup, let's say you're building a prototype for your some innovation sprints, or some you are thinking of any as a proof of concept thing, you need to build everything from scratch. So that is where ROS helps us, and it's important to learn this framework. Next is this key features of ROS 2. So as told before, it's a pluggable middleware. So it easily allows this communication flexibility, supporting multiple protocols and all. and then suitable for applications when there is time critical thing. So you need that particular alarm system or that important system to be at that particular moment of time without any delay between all the robots. So if you are trying to create your own protocol or your own set of system, so there would be a chance of error. And if you are using others the system, there would be a chance of error that it's not compatible to your computer or to your system. So instead of that, you can directly use this ROS as a for this communication flexibility and all. Then comes this enhanced logging and debugging. So in fact, when you are using the modularity of ROS, connecting different sensors and actuators, doing things, you need this logging and debugging features to be very extensive way to be used in your system, because there is a possibility that you might not know where it had gone wrong in your algorithm and all. So in order to debug and all, ROS2 provides already a feature, logging and debugging features, where you can during troubleshoot during the development phase. Next is, yeah, so as I referred before, there is no master required. So earlier what happens is a master is present in the network. So in what a master does is it takes care of all the uh, like where the data should be sent. It doesn't make the data pass through it, but it makes sure to tell everyone that where that particular data is to be sent, or where is this data coming from, to know the address and to know where each one is located, what are in my systems and all. So for that, master was used. But in this case of ROS2, it uses this term called DDS, that is data distribution system. So even NASA and big companies or big organizations use this system called as data distribution system. And what it how it helps is that when you have different components, managing their data together, you need not to have a particular master to manage all of it. You can use this data distribution system, and whoever requires, you just give to that particular module or that particular package or that particular node, whatever your information you want to give. So that's how DDS comes into picture, and this is very robust and it's tested in very different all types of organization. So instead of master, what it does is this DDS, it discovers the node where it's all kept and uses UDP for transmission. So ROS1 uses TCP and ROS2 uses UDP. And this is where DDS plays a major role in avoiding the master thing. And also, so there was, if you could enter into the chat, so there's this quick question: what are the problems you can think of when a master is there, or what are the advantages or disadvantages of a master? There are surely advantages also. You can monitor everything, but can you name the disadvantages of master? So when you will think about the disadvantages, you will get to know more about ROS2, why ROS2 is so revolutionary. Yeah. So getting started with ROS2, first we'll look what a workspace is. So before moving to that, we'll briefly see what how ROS works in. So if you have previous experience with ROS or previous experience with Linux and all, you will see that whenever you write a program or something, you create a particular folder and all, right? You create a proper folder and you create where the particular set of program should be, and the directories to make it organized. So similarly in ROS 2, there is this call con workspace. So how it helps is it. So as we have said before, that ROS is very modular in structure and all that. So in the packages and all, it's very easy to port. So if I am making a particular package in your laptop, you can take this particular package, that is a perception package or navigation package, and just directly install and run it. So you will not have to do any such changes. So this is where workspace come into picture. So workspace is just a collection of packages and tells us how to uh, configure these packages and all. So if you will see, a normal workspace consists of this, that is software packages. There would be a folder called software packages, that is SRC, or where you keep multiple packages. We will discuss also in the next slide what package is and all. And next comes build. So build folder is where you need whatever the build dependencies are there. So let's say you need a particular file requires a particular another file. Let's say that is, if you are thinking about perception, so perception require cameras, drivers, and all that things. So in order to know where the drivers are, all that information is kept in build folder. And next one is that install. So install folder is where after these packages are built, that is the perception packages, navigation, a robot control package is there. Also there will be some packages like just just transferring information from one mode to another mode. So to install everything, like to make sure that is working with your computer, that is where install folder is kept. So install folder has all this information about how this package is installed in your computer, what are the things which requires. So whenever you run or you run the navigation script or something, so this is where it goes to this install folder and looks for the changes in the computer and all that, and then runs the program. So that's how a workspace is built. And finally a log is there. So log is basically whatever during a build or while you are installing this particular package in your computer, whatever error is there, it takes into time and date and creates a file with all the log and debugging things. So if you want to even change the logs, if you want to check for any particular error or warning cases, you can even do the changes in that. So next, as we said, what is workspace is like a collection of packages. So there is no need to be overwhelmed about this package and all. It's just a brief description. We'll not go into that detail. Obviously you will get more details about this in the ROS wiki as well as in YouTube. So would encourage all of you to check or explore more about this. So finally a package. So let's take an example of a perception package, that is some image processing thing. So where you have to let's take the same example as the Krishi bot. You have to detect a fruit. So what you will do in the SRC folder, inside a package, you will create a package, and this is how the structure looks like. So in the SRC folder, you will have all the Python files or the C++ files of how to detect a fruit and all. Then there is also a package. So package will be that same. So if you have created a package name called perception, you will have again a folder called perception. So inside this is where the final uh, callable file will be there. So whenever you call for a particular script to be run, this is where it goes inside the package. So inside the SRC is where you do the changes, but inside the package is where the final callable file will be there. Then include is, as you might all know, all the dependencies, all the header files, all the extra files will be there. Then comes the CMake list. So any guesses like what CMake list package setup from the names are? So for a package, what is the CMake list package setup.cfg? If you have ideas, you can post on, or if you have doubts, you can write it on the chat. We will take. Yeah. Okay. So in the CMake list, what happens is you have more detailed amount of things, like how to take this particular package or how to build this package into your computer. So it will have all the list of dependencies, all the list of directories where you have to paste this particular file, you have to search for this particular header files and all. So this is where the information is there. And then comes the package.xml. Package.xml is where you have the information, a brief description about this package. So who made it, when it was made, and all that brief description about this package. So in future case, you can use it more, even other than this description also you can use it. I would encourage more you to explore into this. And then there is setup.configuration. So all the configuration, how to set up it, this package. So this is how a package is made. So this is what is the modularity part of ROS. So where you can directly use this particular package and give it to your friend, give it to another company. Even you can use another company's package and even put directly into your robot and test it. So as we were talking about nodes and topics, we'll quickly just see what a node is. So node is something as you might see in your daily life. So node is like, let's say you have one particular robot and you have your computer. So you can consider your computer as a node and a robot as another node, just for in this case. So what you will do, the robot will send the message, whatever it's seeing on from its camera perspective. You are receiving it on your computer, and on your computer, what you are doing, you are sending messages to move forward, move backward, left, right, or to stop. So that's how you can understand of a node. So in ROS, what it happens, each program or each set of code or each set of Python code or each set of C++ code is a node where it will publish some message. It will another node will subscribe some message. So this publishing and subscribing happens on a particular topic. So let's say if you have a camera, you will send image information on an image topic. Like let's say, or you can take this example of YouTube. When you have this video on a particular channel, you take this channel name as a topic, and on that particular channel name, you are getting that particular video, different types of video whenever you are subscribing to that particular YouTube channel. So similar way, when I am requesting or not requesting, in fact, I will be continuously publishing my data that this is the images I am getting, and from the computer I will subscribe to that image and do the navigation part. And similarly, what the bot will do, the bot will listen to the commands which it has to go, move forward, move backward, and all. And my laptop will publish the messages to move forward or move backward. Yeah. So this is what nodes and topics are. So in fact, these topics can be one to many, many to one, or many to many also. So it's not just that one robot, one computer. You might have also your friend computer, or you might have also two robots on this thing, and you have to share information about each other. So what one robot is seeing, also you want the computer, two computers, that one your friend's computer as well as your computer, to subscribe to that particular topic. So in your both of the computer can get the same message at the same time. So there will be no loss of messages, as well as it's like a typical publisher and subscriber model. So at the same time, if you will see on the second part of this animation, that two publishers can also send message on the same topic. So let's say a different robot is there, and it also wants to publish message on the same topic, that is an image again. So if one robot is down, it can take the camera reading and send the message on the same topic. So parallelly also it can send. Okay. So next are services. So in services, what happens is, so if you would have seen in the like previous topic, that is publisher and subscriber model, you would have seen that there is a bit of problem here. So what happens is, the publisher is blindly publishing all the information, and the subscriber is waiting for the information. So there is no feedback going on. So that is where service model comes into picture, and this is where you request for a particular information, and then a server will be there, server who is waiting for any request. Whenever the server gets a request, it will give you a response. So this is what we call as synchronous mode, or a feedback system. So can you think of all the applications which a service is used? So just think of what are the service model used in. So there is this publisher subscriber model as well as this service model. So there is this server as well as service client. So in a service server, you request for a response, and the server will in return will give you a response. So where this can be particularly used, yeah. So there is one response, like one of the participant is saying that ATM it can be used. Yeah. So ATM, you go there and then you are requesting for some money and all. So that's how services goes on. You request for a service and then you are getting. So it's very useful in terms like whenever you are in a in a particular where you need a response, you need to know that that particular thing has got the information or not. So for example, you have a arm that is a robotic arm, and you have a gripper attached to it. You want to know that it has closed or opened even though you are giving a command. So if you are using publisher subscriber model, you are blindly giving one to open the gripper, and all. So that's not the ideal way it should be done. You need to give a request you need to give a request that to open the gripper, and when the robotic arm finally opens the gripper, it will give a response, yeah, I have completed opening the gripper, now you can proceed further in the next or continue the task. So that's how services are very useful, where you need a particular information to be true, and to be made actually you need to verify that it has received or not. Next comes the actions. So action client is one of the third feature of this ROS. So this is where most of the robotic arm, or where the navigation, the big tasks are being used by. So what action does is it will take care of it does all the functionalities like service client. You send a request, you will get a response, but at the same time, if you will see in the animation, in the center of this action is present a feedback topic. So what happens is, let's say you are giving a request, and it's also giving a response also that it has completed. But meanwhile, during the process, you have no clue that what is happening to my particular robot, or what is happening, where is my robot at current position and all. So in order to fulfill that requirement, actions are used. So let's take this example. So you are giving a robotic arm to move to a particular position. If you are using service client, what will happen? You are giving a service that yeah, go to this particular position, and the arm will take time to go to that particular position, and after reaching that particular position or not reaching, you will get a response, failed or success. That's the only thing which you can get as response. But in actions, what you can get is, meanwhile the robot arm is moving, you will continuously get a feedback topic stating that, okay, I have reached to this particular position, or I am taking more time at this particular position. This is my velocity, this is my acceleration, and the power supply to me, and all that. So continuously you can get a feedback topic. So it's almost similar to service client, but at the same time, you will have this feedback topic which is continuously moving in between and getting your information, updating the information about what the robot state is in. So yeah, now we will move on to the hands-on session. That is, we'll look on to use this ROS. So if you will see this, yeah. So I have typed LSB release -8, and it will throw out all this current version of Ubuntu and all. So the one which I am using is Ubuntu 22, that is Jammy, and Ubuntu 22 supports ROS2 Humble, that is the Humble version of ROS2. So we'll quickly jump on to this. That is Turtle Sim and all. Okay. So in what is Turtle Sim? Actually, is a question. Okay. Okay, I will reshare my screen. I guess now it's visible. So yeah. So what is Turtle Sim? So Turtle Sim is like actually uh, uh, basic programming interface, basic graphical interface which is given to learn what the publisher, subscriber, service, and all that. So how did I open this terminal? Is a quick question. There is this either you can use this terminal which is present on your laptop or in Ubuntu, that is by using Control Alt T. So we'll repeat again, Control Alt T. So either this terminal or there is this software as Terminator. So in the Terminator, if you will see, you have this four. You can split up more. Like you can right click and split more. So basically, you can open multiple uh, terminals in one particular window. So first, we will understand what is this command. So the first part is the ROS2. So where we tell the computer that this is the ROS2 commands which are going to come into picture, and then the run. So there are different types of this uh, types of ROS2 functions. So first we'll look on to that. Okay, we'll better look into this. Yeah. So ROS2, and then if I press double tap, so in that case you will get all the list of the types which ROS2 offers. So there is this, if you can see, action, bag, component, control, all these things. So you can, if you want to learn more about it, let's say if you want to learn more about run, so you just type run and -h, and it will show what run is. So it says to run a package specific executable. That is, if you want to run a executable file, so the positional arguments will be that first argument will be a package name. So we have seen in the slide of what is a package. So in this case, TurtleSim is a package which is already available. So when you install ROS, you can find package name. So after this part, we will also share how to install ROS and all. It's a time-taking process, so that's why we skipped on the start. We'll fresh up with the hands-on part, and then the executable name. So if you would have seen, we are using this TurtleSim node here. So TurtleSim node is the executable name. So that is a file which has all the graphical interface part, the code written and all. So if we execute this, there opens up a window that is TurtleSim. So we can just right click and keep it on always on top. And yeah, and then comes this. There is another. Okay, so this is the TurtleSim package, and that's how you run you spawn a particular turtle. So next, if you want to explore more, what are the more things that TurtleSim offers? So after you write the package name, you can just double tab. So use the tab key and press 2 times in consecutive manner, and then you will see that there are different nodes which are available. That is draw, square, mimic, TurtleSim node, turtle, teleop key. So what is turtle teleop key is that if I will write turtle teleop key and then use tab to finish it. So in Linux there is this option called as you can use tab to finish. So it will automatically complete whatever is similar keyword present in that particular directory. So turtle teleop key helps us to navigate this turtle inside this window using teleoperations. So teleoperations like using arrow keys. So if we enter this, it shows that use arrow keys to move the turtle and use these G, B, Y, C, D, R, T to rotate. So now if I will use arrow up key, you will see it goes straight, and then left it moves, almost it rotates, and then again if I move forward it moves in a particular direction according to the arrow keys. So this is how you see that the turtle teleop key node that is here on the my second part of the screen on the right side of the screen is publishing my like directions, commands, and all that to this turtle sim. So this right side is publishing, and whereas at the same time turtle sim is subscribing to it. So if you want to see what's happening on the background, there is this tool called RQT graph. So now you will see, you will think, what is RQT graph? So now I explained you in verbally that a particular node is publishing, another node is subscribing. But if you want to visualize that, you can enter into this terminal called RQT graph. And when you enter it, it will take some time and it will open up a window. Uh, yeah, we'll just hide it. It will open up a window showing all the connections between the nodes. So this is one node, turtle sim, and this is another node, teleop turtle. So if you remember, we opened this turtle sim, right? We opened on left side of the terminal turtle sim, and on the right side we opened teleop turtle. So as we have seen, teleop turtle is publishing CMD well, that is command velocity and all that, and turtle sim is subscribing to it. And if you will see, apart from this, there are other things also going on, action, feedback, and all that. So if you want to see more, we can explore more about it. So let's say we go back to the terminal and we'll see what are the topics going on. So you would have seen there are three types, right? Topics, service, and actions. So they, if you want to see about ROS2 topics, what are the topics? We can do ROS topic minus H, and it will show all the commands which are available. There is echo, find, type, list, and all. So what we can do, ROS2 topic list. So it will show us all the topic list which is present in this network of ROS2. So there is this parameter events ROS out. ROS out is actually a topic where all the logs are present. And then comes the command velocity, in which the right terminal is publishing and the left terminal is subscribing to. So if you want to know more about it, what we can do is ROS topic info. You can use this keyword info and then use turtle one CMD well. So it will give out all the information. So the type of the topic is twist messages, and it has one publisher, it has one subscriber. So if you want to know who is the publisher and who is the subscriber, you can turn on the verbose level. So verbose level is like you want to more information or not. So if you will do that, you can see subscriber is turtle sim, that is the left node, and then the publisher is teleop turtle, that is the right one. So you can see now, you can intuitively understand or debug. So this is how you can debug. If you are using another package of any other person, and if you are running but you are not able to understand where is this things going on, what are the publisher subscriber going on, you can do either RQT and do all that thing, or you can go to the command line and do the same things. So now a quick deviation from uh, the way we are going, that we have written ROS to run turtle sim package and all. So these packages are installed inside our system, that is inside the main part of the system. And then if you want to tell our terminal where all these things are, so there is this thing called bash rc. So if you will go and unlock the hidden folders, so there is this called bash rc. What happens is, before you start any of the terminal, so whenever you open a terminal, it goes to this bash rc and executes all of this. So there will be a lot of things, you need not to worry about it. We are only interested about this part, the last part. So while you are doing the installation, you will be commanded to enter this part on the last line of bash rc. So what it does is, there is this setup.bash. So you are sourcing it inside the terminal. So that's how the terminal gets to know what is the name of the package. And when we did double tap, it also suggested what are the nodes present inside this. So all this information is inside the setup.bash. And how the terminal knows about setup.bash? Because we have written inside bash rc. So before terminal opens up, the terminal executes all the things inside bash rc, and then our terminal starts. So that's how it gets to know where the packages are and what are the contents inside package, right? So now moving forward, if you want to know more, like we have seen the topics, now things that is left is service. So if we'll see the ROS to service, so we can see what are the service available. So there are, I will take it back again. Okay, bring it bit here. So yeah, these are the services available. So if you want to see clear, kill, reset, these are the services of this turtle sim. So now if you want to know more about service, what is this particular service about? So you can do ROS to service info, and let's take this example of clear or kill. Okay, let's take this example of clear. So ROS to service info clear. So it will give us this info about, oh sorry, yeah, type. We'll see the type, and it will show that it's an empty type. So we'll just call this service and it will do the activity. So the type is actually we are telling the service or the topics that what type of message we are going to send. So I will show you with an example. So ROS to service call clear. So if you want to call a service, this is how you do. You use this keyword called call and then double tap. So it will show you what is the type of the message which is needed for this particular service. So if you see, it's suggesting standard services empty type. So that means this is the type of the message, and now we have to enter the message. So it's saying that it's an empty type of message. So we need to enter just empty braces. So if you will do double tap, it will suggest you what are the next keywords which you need to enter. So if you will see, just clear this, yeah. So ROS to service clear standard, the type and the whatever the message we have to send. So we'll first decode it and then execute it. So first ROS to, again ROS to is telling the computer the command which are to be executed using ROS2 features, and then service is the type of communication which we are using, ROS2 service, and this is the service which we wish to call, and to call this service we are using this call feature. So there are different call info, not info, but there are call or to list all the services. So since we are calling it, we are using call, and then the service name. and then the service type, that is empty service type. So in the service type is where we say it's an integer string or it's just a trigger service. So usually, since this is a trigger service, and so we are using this empty message type, and then just curly braces to indicate that we are passing nothing. So if we execute this, we'll see all the lines which was drawn on the turtle sim um, is just vanished off. So it clears off. So if you'll see, we made a request, an empty request to this clear service, and in response we are getting, yeah, it has done the part. So that's how service works. So if you want to explore more, you are free to do. You can try out other services also. So there are lots of service that set pen and spawn. There are reset. You can even spawn. You can change the color of the turtles and drawing. You can spawn on particular position. So you can take another example of service spawn, and you see the message type is different. It's called turtle sim service spawn. So we can also see what is inside that. So yeah, uh, clear this off. Yeah. So this is the message type. So we are entering in the x position of this spawning, y position, and the rotation which should be there, and the name of the turtle. So this turtle has the name as turtle one, and similarly, if you want to change the name also, you can do that. So this is how you like I've closed it. I didn't execute it because we have to change the values. So this is how you debug it, or you explore different services, different topics, and all that. So if you want to see what a topics is also, so we have also seen in the RQT graph that this particular teleop, sorry, yeah, teleop turtle is publishing see on CMD well topic to turtle sim. So if you want to visual, like if you want to watch it, what it is doing, what we can do is ROS to topic. First we can list to find the name, and we see turtle one CMD well. So what we can do, ROS to topic echo. So echo is used. Okay. If you want to see what are the suggestions, so echo is used actually to listen, and pub is used for publishing, type for seeing what type of message it is, and info, it details out all, as we have seen previously, who is subscribing, who is publishing, and all that. And more features are there, the bandwidth, delay, and all. So if you want to see about, if you want to echo the topic, that is turtle one CMD well. So right now nothing is being published. So to see that, we can go to this terminal. This is where we were publishing the command velocity, and we will use arrow keys. So if you'll see, the moment I press the arrow key, there was this information which is echoed. So this is how you can debug, or you can listen what is happening in between them. So the left terminal is subscribing to the right terminal, and it's publishing. But at the same time, if you want to hear that, you can use this cross to topic echo and see. So what we have published is, it goes in a linear velocity of 2 units, and y and z remain 0, and angular also everything remains 0. That's why it moved a 2 unit in forward linear velocity in its x-axis. So its x-axis in its current position is pointing to its forward direction. So that's a brief introduction about ROS2. Um, Also, if you want to see more about, okay, I'll just keep it away. Uh, ROS2 install Humble. So every ROS2 has, every ROS has its own specific build for a particular Ubuntu version. So Humble is used for Ubuntu 22. So if we'll directly search for ROS to humble installation, it will show you all the things, how to install and all. So there is this Debian packages, and these are the commands. So it's very simple. You just have to do this after going through the steps. You just have to type sudo apt install ROS humble desktop, and it will install all the basic necessities of this turtle sim, even and basic features which are needed in the ROS to communication, to create packages, and to install other packages. Everything will be installed. And this is where I have told you in the bash RC this thing is to be sourced. So after installation, the setup.bash contains all the things, all the list of where the packages are, and what are the things, what are the nodes, what are the contents inside particular packages. So that is one thing. And you can find use this documentation to even learn. Uh, uh, Go to this tutorials part, and here you will find how to write a simple publisher a subscriber in Python, all that details. You can use this particular docs.ros org website to learn yourself what the publisher subscriber is, service client, and then there are intermediate and advanced level also. So that's a basic introduction, and we'll quickly, yeah, these are the references. So the left one, the arm which you are seeing is the UR5 arm that is built by Universal Robots, and if you want to search more about it, you can use the links. And yeah, so we'll take up questions one by one. Any questions? Okay, to change the window size, you can use either you can go to the particular Python file that is the node, and you have to manually change it, or else you have to either uh, go create your own custom turtle sim node. So that's how you can do that. Or there are many different ways. I would encourage you to surf more about it. So that's how you learn. So turtle sim, it's just a basic 2D visualization tool to just check everything, or it's a beginner tool to learn publisher subscriber and everything. And after that you can move towards navigation of perfect big size robots. So there is this turtle turtle bot simulation that is in Gazebo and all. So also I would like to show in the previous slides Krishi bot. Yeah. Uh, yeah. So this is the simulator, that is Gazebo simulator. So in Gazebo simulator, it simulates everything, the world and everything. uh, Everything as you would like to. So you can change the gazebo simulation how it looks like your real world things. You can change the color and the physics and all that. So here you can test the physics, all that movements, how your algorithm works. So this is what I was talking about simulation. Also, there is this tool in ROS called as RVIS. So that is robot visualization tool, RVIS. So what you see on the right side of the screen, that is RVIS, in which it shows the robot visualization. So what robot is perceiving from its frame of reference, or what robot intends to plan and all from the robot's perspective, we can use RVIS. So here it detected a yellow fruit, and it's pointing the distance from it. So it calculated using a depth camera. So in depth camera, you know, you get X, Y, and Z also. So that's how you localize a fruit and you tell. Here you can even know what the arm is, robotic arm is going to plan, and is it colliding it with something else? Is it colliding it with itself or not? All that things. For that you can use this RWIS. So and then finally you can test it on real hardware. And yeah, you can use any other ROS version. Okay, so there was this one query that can we use other ROS versions? Yeah, perfectly all right. But make sure to check which ROS versions are compatible with which versions of Ubuntu. So for Ubuntu 22, there is this ROS Humble, and there are this. These are the long-term stable systems, stable ROS versions. Also, there will be other ROS versions such as rolling and all that versions. So that is for development purpose, but the long-term supportive ROS versions like melodic, noetic, and all that, you can use it with respect to each of the Ubuntu version. So before installing it, check which Ubuntu version you have, and then install and do the part. So the next question is that can you give a roadmap for learning robotics? How to learn step by step. Yeah. So for learning robotics, obviously you will have to take two things in parallel. That is, at the same time you explore more of this technical features such as ROS and all that things. At the same time, in parallel, you have to also take into account all the particular stacks of robotics, that is image processing and the control system part, where you are moving towards, like for robotic arm manipulation you have to learn about kinematics and all, and for navigation you learn about PID, and then you have slamming, your localization and all. So all the mathematics and all part you need to do it parallelly. At the same time, do the technical part also on the other hand. So when you are taking it go hand to hand, you take one feature, and let's say if you are planning to start with ROS, and the same way I have shown you in the ROS documentation, go to the ROS documentation. There they have provided tutorials for each of the step, from intermediate, beginner to intermediate to advanced and all that. Go through it one by one, and most of the queries which you will be facing while you are doing that would have been already solved in the internet. So if you will just copy paste the error which you will be getting into the Google, you will be easily able to solve it. And then on the other hand, where you have this all the concept part, that is kinematics, control system, image processing and all, would like to prefer take any one of them at a time, and go to YouTube and search for your own channels which you would wish like to have more, if you, that you are more comfortable with, and then proceed with learning more about it. Yeah. Okay. So another query was, does ROS to support Windows? Yeah, it supports Windows, and you can easily do the basic stuff, all the publisher subscriber surveys and all that thing, and even more complicated stuff like navigation, manipulation, and all. But at the same time, there are support deficiency. That is, more of the developers are focusing more into Linux, and more the industrial part is focusing on Windows. So there are support for Windows, but would be less compared to Linux. So would prefer Linux only rather than Windows. So once you get into the Linux environment, also you would find it very easy to do things in Linux rather than in Windows. All the features would be very accessible. All the core things would be very accessible to you. Okay, so which one is the best? Dual booting or yeah, ROS on virtual machine? So in dual booting, it would recommend the best because in dual booting, what happens? All the memory and all the CPU is taken care of that particular operating system. So if you are on Linux, the Linux will have all the access, all the full access to that particular CPU and RAM. But at the same time, if you are using virtual machine, you are allocating, and at the same time, the host operating system will be consuming some amount of RAM and all that things. So it would work in virtual machine when you are doing light amount of stuff, all the light amount of operations in ROS. But at the same time, if you want to do more complex things like simulations and all, there you would feel a lag based upon your computation. So it is possible, obviously, you can do in virtual machine, but at a cost or at the risk of your computation. Yeah. So yeah, for cosmologistic theme, Ubuntu 22 is required, and it would be required because all the packages and everything was is made based on Ubuntu 22, and it is more stable with compared to other ROS2 versions. Okay, so if you have any other questions, you can post it on the chat. Yeah. So one more question was that yeah. So we were using Intel RealSense DepthCam, and which processor are compatible with it, or big DepthCam? So uh, it is not like processor compatibility. It is main upon the package compatibility. So certain drivers, not actually even package. So the drivers which are written for that particular depth cam should be compatible to the. So you have to see on the internet that if you are using RealSense depth cam, the drivers which are available, is it compatible or not? In with regards to ROS package, once the driver is set up and everything, you would be easily able to take the. It's all about you are taking the feed and converting into ROS topics and all. So yeah, highest capability, I would recommend that since we were tested it on NVIDIA as well as on Intel. So in both cases, it works perfectly. Uh, Even on ARM processors, it would work. So it's not about the package; it's all about the drivers. If you are able to install everything perfectly in the driver, it's fine. So this is the theme film or the launch film of EVA-RC this year.
Did you like what you saw? What if we told you that you too can do such cool stuff? It doesn't matter how much you know. All that matters is whether you are willing to believe in yourself. Welcome to e-Yantra Robotics Competition 2023-24, which is actually a skilling program disguised as a competition. We've trained over 200,000 students over the past decade in futuristic engineering skills using project-based learning. This year, we're going international. We welcome students from across the world, collaborate, make friends with like-minded students in India and abroad. e-Yantra is a unique experience. It trains you, then makes you compete to discover your true potential. Every year, we train tens of thousands of students in complex engineering skills. Outcomes are top rate placements, the urge to do higher degrees, and spontaneous startups. This year's theme, The Space Beyond, we train you in exciting technology stacks through our themes. First in a simulator, Then on hardware, in teams of 2 to 4 members, the prizes are cash and a 6-week unique internship at IIT Bombay. The competition is open to everyone across the world. Any student can participate. Registrations are open from the 1st to the 25th of August 2023. Register at portal.e-yantra.org. Join us to explore the world of robotics and embedded systems. Discover with us the joys of engineering and the best version of yourself possible.
So yeah, um, referral code will be shared to you. So if you will go to google.com and just write eYantra, robotics competition, you will see there is a portal.eyantra.org. So if you'll go to this website, you will see all this poster as well as registration link. So we'll go down beneath on this section. Uh, yeah, where it's about the fees per team. So maximum take up to 4 members in a team and minimum two. And this is the price. So if you are on eLSI college, you will get extra 15% discount. And there is this referral code which is being shared on the chat. You can use that to gain more additional discount and all that. So, and also apart from that, there is this early bird discount that is till 7th of August. If you create a team and register, make sure you do it first, and make sure you do use referral code and log into it. And yeah, if you want to know more about themes, you can click on this theme tab, and you will see there are, in fact, 6 themes on this particular e-Yantra robotics competition. And if you want to know more details about it and the system requirements, learnings, and all, you can just double click that and it will open up. So there would be exciting themes, that is drone, self-balancing bike, and all that. So make sure you check out everything and register as soon as possible. Yeah. Okay. To for build a robot, ROS2 is enough to build, or what are the softwares we want to use? Yeah, ROS2 is a framework. So using that framework, you can build a robot. But again, it depends upon what robot you are talking about. You can look into the internet and you can see directly the packages what we talked about. You can directly use the packages from the others who have already made that and do some changes and then write your code directly in that packages. So you need not to build everything, the communication part and all. You just enter where the camera is, which is the pin where the motors are connected and all, and it will start to work as efficiently as it was working in their robot. Yeah, you don't need extra any software apart from ROS2. You just use this framework and write your own Python code. That's it. And then from software perspective, ROS2 is much enough capable to handle. Okay, is there any question left? You want, you can enter into the chat and we will be happy to answer, or else we can wind it up. Any questions regarding the robotics competition, ROS, or any other themes? I guess we can then. Okay, one more question is there. In eVALC, when will the task be given? Yeah, from September onwards, we'll start the task and all. So yeah, the stage one, as mentioned, it will be in simulation. So after simulation, there will be cut short of a number of teams. So after that, those teams who are selected will be given hardware, will be shipped hardware to their colleges, or if it's a remote team, you will be given remote access to the hardware. Yeah. Okay, we'll shortly share a quiz with all of you, and would encourage all of you to write up, like, participate in that quiz. That would be a small quiz regarding how much did you understand about ROS and the feedback and all. We can select our own theme, or we want to perform the theme. So it's like you would prefer, you would give your preference about the theme, and based upon your like your desire for that theme, as well as whatever you are compatible, based upon your compatibility. So we'll ask you some questions and all. So based upon your preference, mostly would be preferred one will be given to you, but also if that is not possible, based upon the compatibility of your subjects and all, that will be allotted a theme. So yeah. So what you have to do in the team is like, so we'll be giving a training of, we'll be training like a MOOC style part, where you will be given all the contents related, how to solve the task and all, and then you will be given a task. So first part would be you will be trained on particular uh, stack, that is, let's say, image processing, and then you will be given a task of detection of a particular image, object, or anything. Okay, so we have shared a quiz link in the chat. We'll appreciate all of you. So those who are in the WebEx are requested to do the attend the quiz. So we can open up, and there would be few questions regarding the sessions and few technical questions. Make sure to fill up it as soon as possible.
So I think we can conclude the session, right, Jason? Hello?
ఎందుకు ఇస్తున్నారు? Okay.
chat box.